Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just absolutely love what we get to do here, which is hang out on Wednesdays. Sorry, I have a hair in my eye. Hang out on Wednesdays together, solving math problems, just to help you increase your competence and confidence in your ability to move forward in those math exams. Happy New Year. I went to my friend's Zumba class this weekend and we all wore Happy New Year glasses. And I thought, what better way to start off the new year in Wednesday Night Math Night than wearing these awesome glasses? And so we'll see how long they last. I have my other glasses ready to go just in case. But Happy New Year. Glad that you're here. It's going to be a great year. 2025 is going to be a great year for you because I'm confident this is going to be the year that you pass that exam that you are trying to pass. These exams are not easy. We know they're hard. That's why we are here every Wednesday to help you get over that hump. So Happy New Year. Hello, Sean. Good to see you. Happy New Year to you too. What else? We will do about 8 to 10 problems. Sometimes it's a little bit less, sometimes it's a little bit more, but we do about 8 to 10 problems every week. We are here every single Wednesday, unless, something crazy happens, like I'm sick or whatever. But we are here every Wednesday, just solving math problems. I always have a next week section running. And so if there is something that you want to see me go over in the upcoming weeks, don't hesitate to let me know. Let me know in the comment box, and I would be happy to include that. Hello, Leanne. It is good to see you as well. Happy New Year. I hope you guys had a great holiday season. I am aware not everybody had a great holiday season. And so if that was you, just know that I am thinking of you and I am sending you tons of love because I know that we have a staff member specifically that just didn't have a great a great holiday season for a variety of reasons. And so I recognize that not everybody had a great holiday season, but I hope that you did. Hello, Hope. It is good to see all of my friends, all my familiar faces. So yeah, and we are thinking of those that are affected by the crazy wildfires right now. And so that is definitely heavy on my heart as well. I just had a friend literally fly out to the West Coast yesterday. They are moving out to Oregon. And while she is not affected by those fires, it's just a little too close to home. And so we are definitely thinking of all of those that are affected by those fires as well. It is scary. And so if that is you or you have family that is affected by that, please know that we are thinking of them as well. Enough about me. I want to learn a bit about you. So in the comment box, let me know where you are from. What test are you prepping for? And what is something that you did over the holiday break that just brought you joy? Where are you from? What test are you prepping for? And what is something that you did over the holiday break that just brought you joy? Something that I did over the holiday break that brought me joy was just spend time with my little one. I absolutely loved all the little moments, all of the magic through his eyes. He's almost 3. And so it was just so fun to see the holidays through his eyes. He asked Santa Claus for cake this year. Yes, he sat on Santa's lap 3 days before Christmas and asked Santa for cake. So Santa Claus delivered and brought him the cutest little stuffed animal cake that Santa could find. It was super cute, but little kids ask for the darndest of things. It's adorable. So that's something that we enjoyed as a family, was just seeing the magic through his eyes. So where are you from? What test are you prepping for? And what was something that brought you joy over the holiday break? Sean, just spending time with family and friends. That is like the best part of the break for sure. You're from Texas studying for the EC6 exam and you bought yourself a Nintendo Switch. That is awesome. We have a Nintendo Switch as well at home. And so I'm so proud of you. I love that you just did that for yourself. Sometimes it's hard to do stuff for ourselves. And so that's awesome that you were able to do that. We're going to go ahead and get started with problem number 1. We've done enough talking about the New Year and Christmas and fires and all the things. But let me know in the comment box, what you want to see in the upcoming weeks. You did not play the oven mitt game. I love that you played the oven mitt game. You are prepping for the pre-admission test for mathematics. That's fantastic. And then moving on to math 4 through 8. The oven mitt game is so fun, is it not? I just love the oven mitt game. And we always have, like I said, we always have 2 presents going. And so there's always one with a good gift and one with, a gag gift or like a silly gift. This year it was, what was the silly gift this year? Oh, it was more of our wedding koozies. So we've done wedding koozies for 3 years. Mind you, we got married 5 years ago. And the first year we did wedding koozies and then we did something else. And then the next year we did wedding koozies and then we did something else. And so this year we did wedding koozies again because Lord knows we have way more wedding koozies than we need. So if you want a wedding koozie, let me know. I'm happy to ship one to you. But yes, I love that you played the oven mitt game. That's awesome. Happy New Year. You are from Massachusetts. That is super far north and you have cold weather a lot more than we have cold weather. But I am telling you, Florida is experiencing some cold weather that we are not used to. I personally absolutely love it. I live for the cold weather. But a lot of my Florida friends are not so fond of this cold weather. But I am loving every second of it. Woo! Sorry. I'm going to have to get my water in a minute. Okay, let's go ahead and move on to problem number 1. I always cut the camera, read the problem out loud, and then we solve it together. So if you have questions, let me know. That's what this is. That's what we're here for. Let's go ahead and move on to problem number 1. A store owner wants to set up a rectangular sale zone to display sale items on the pavement outside of his store. he will use one side of the building, which is 35 feet long, as part of one side of the display area. He will use 210 linear feet of fencing material to fence in the remainder of the display area. Let X represent the length of the side of the rectangular sale zone, which is opposite of the building. Write a function that expresses the total area A of the sale zone in terms of X. And then we've got our answer choices listed out there. All right. Yeah, we'll do that. So a store owner wants to set up, I was about to use my pen to literally write on my iPad. That's not going to work. So a store owner wants to set up a rectangular sale zone. And I'm going to have to write small for this one because I've got a lot of my space covered by the problem. But we have this rectangular sale zone to display items on the pavement outside of his store. So let's say this is his store. And then this is the pavement, right? He will use one side of the building, which is 35 feet long. So this is 35 as part of one side of the display area. And he will use 210 linear feet of fencing to fence in the remainder of the display area. Let X, this piece is important. Let X represent the length of the side of the rectangular sale zone, which is opposite the building. So this over here is going to be X because it's opposite of the building, right? Write a function that expresses the total area in terms of X. So we know that we're doing area equals something, right? So I know I'm eventually going to have area equals. Well, we know that the area of a rectangle is length times width, correct? Area equals length times width. This is definitely a problem that is going to be for my middle and high school people, if you were wondering. However, that's what I forgot to say. I always like to make sure that at least something in every problem is relevant to everybody. So everybody needs to know that area equals length times width, right? Everybody needs to know area equals length times width. And so the rest of this problem is really going to be more middle school and high school. We have problems for everybody tonight. Don't leave if this seems like it's too hard for you. But it's important for us to all know what area is. So area equals length times width. I know that this side of the building is X and this side of the building right now is W. You can call it L. It doesn't matter which one it is, but one of them is L and one of them is W. And I know that this right here is going to be X minus 35, right? Like if this whole thing is X and the store is 35, then I can take X, subtract that 35 out, and that gives me that piece. Elementary people, that's just your part whole model. So if I'm looking at my whole is here, and I have a part and I have another part, and this is important for you to understand, then in this model, my whole is X and one part is 35. So how do I find the other part? You do whole minus part equals other part. So X minus 35 equals that gap, right? So there's another tie for my elementary people. And so I know that my area is going to equal length times width. So I know that my area is going to equal X times W. But I need to get rid of the W and put W in terms of X because they've told us they need everything in terms of X. So how do I figure out what W equals? Well, I'm going to use my perimeter formula, which is why they gave us that. They don't usually give us information that we're not going to use other than like, this kind of stuff, like the extra words. But usually the information they give us is going to be used. Not all the time, but usually. So we know that the perimeter is going to be 210 almost. So the fencing is 210 and then plus the store is 35, right? And so I know, and you can approach this in two different ways. I know that I can do X plus W plus x minus 35 plus another w is all going to equal 210, right? Because I did x plus w plus x minus 35 plus w all equals 210. Add 35 to both sides. And I get x plus w plus x plus w equals 245. Now, if you wanted to approach this a little bit differently, and you wanted to do, okay, I know that 210 is the fence, plus the extra 35 is the whole rectangle, so that all equals 245. And then x plus w plus x, that's fine too. You end up with the same thing we do. So we have 2x plus 2w equals 245. Now, I need to know what w equals in terms of x. I need to figure out what w equals. So I literally need to solve for w. So I'm going to subtract 2x from both sides. 2w equals 245 minus 2x. Divide everything by 2. W equals 245 divided by 2 minus x, because these 2's cancel. Now what I can do, y'all, is now I know area equals x times w. I can replace w with this guy down here. 245 divided by 2 minus x. And I'm actually going to replace this multiplication sign with a dot. Now I can distribute. So area equals 245 divided by 2 times x minus x squared. Which answer is that? D. Interesting problem, huh? That took us a while to solve, but I wanted you to have the full perspective on how to solve it so that you would know how to approach something like that in the future. Questions? Comments? Concerns? Let's go ahead and move on to the next problem. A geometric sequence begins as follows. 4, I, ... What is the next term in the sequence? What is the next term in the sequence? All right, so let's just chat about the difference between an arithmetic sequence and a geometric sequence first. An arithmetic sequence is a sequence that has a common difference, something that's being added or subtracted to each term to get us somewhere. A geometric sequence is something that has a common ratio. So it's something that's being multiplied or divided every time to get us to that common number. And so we have an arithmetic sequence and a geometric sequence. In this case, we're looking at a geometric sequence, which means that we are going to have a common ratio, right? A common ratio. And it begins as follows. 4, I, ... So if you're like, golly, I don't know 4 times what equals I, what in the world? How do I even start that? Here's what I encourage you to do when you get stuck on a problem where you're like, I don't even know how to start that. Create your own problem that makes sense. So I'm going to create a geometric sequence that's very simple, that has numbers that I understand. So I'm going to say 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, ... right? And I know I'm multiplying by 2. But what if I didn't know that? What if I didn't know that and I wanted to figure out what that common ratio was? Well, I can just divide, right? The opposite of multiplication, which is moving this way, is division, which is going this way. So I can do 12 divided by 6, 6 divided by 3 to figure out what that common ratio is. So 12 divided by 6 equals 2. That tells me I'm multiplying by 2 each time. So now 24 times 2 is 48. That would be the next term. Let's use that same exact process to figure out what the common ratio is here. So if I did division, then I'm going to do, and I'm going to make this a little bigger so that we can see, I'm going to do I divided by 4. I divided by 4 is the common ratio. So 4 times I divided by 4, well, hello, that equals I. So that is our common ratio. So now I know that I am multiplying times I divided by 4. Well, what is I times I divided by 4? Great question. Let's go ahead and explore that. I times I divided by 4. Now, this is that piece that I was telling you about that relates to everybody. This is the elementary piece. Yes, you don't have to know imaginary numbers, but you have to know how to multiply fractions. So if this was a normal fraction, how would we multiply it? I have to take that first term and put it over 1. So instead of I, it's going to be I over 1 because I know that when I multiply fractions, I can go straight across. I times I equals I squared. 1 times 4 is 4. I squared equals what? -1. If you didn't know that and you're taking the high school exam, 7 through 12, 6 through 12, 9 through 12, you need to know that. I squared equals -1. So this equals -1 over 4, which is F. That's a fun problem, y'all. Questions, comments, concerns? Let's move on to the next problem. Which of the following functions could correspond to the graph below? Which of the following functions corresponds to the graph below? All right, so there's a couple of different things that we need to know about functions in general. So if I have a function and I have some x-intercepts, right? If I have a function that goes through the x-axis, that means that it has a multiplicity of 1. So, and I'll talk about what that means in a minute. Jeff, thanks for that. Appreciate it. You're welcome. So if I have a function that goes through the x-axis, I have a multiplicity of 1. If I have a function that bounces off the x-axis, it means that I have a multiplicity of more than 1, right? Leah, it is good to see you. Happy New Year, my friend. And so when I look at this graph right here, I can see that this x-intercept is going through it, which means it's going to have a multiplicity of 1. But this one right here bounces and comes back up, which means it's going to have a multiplicity of more than 1. I also know something about this cubic function. Because its end starts down here and goes up, then down, then up, this is a positive cubic function. If it went like this, then it would be a negative cubic function. I always like to think of it as my car is starting up. And so if I had a car, the car starts by driving up, which is why it's a positive. If it's going like this, the car is starting by going down. So then that would be a negative. We read words from left to right. And so we read graphs from left to right. So with that said, I know it's positive. So I can get rid of C because C has a negative out in front, which tells me that that graph is going to be doing that graph is going to be doing something like this instead. Now, which of my zeros has a multiplicity? My 3 has a multiplicity. My -4 does not have multiplicity. So multiplicity means that it is squared or cubed or something like that. So this right here tells me that that has a multiplicity. So because A has no multiplicity, and I can see that because this is a plus and this is a minus. If this was a plus and this was a plus, then that would also be multiplicity as well. So if this was plus and this was plus, that would also be multiplicity. And my screen just froze, but I think when this happens, we are still live. So that's why I just pulled out my phone, because I'm checking our YouTube page to see if we are still live. And yes, we are. So as long as we're still live, even though my screen is frozen, we are still going to move. So if this was a positive, then that would mean that we are that we have a multiplicity. Just a short break in service, no big deal. Here we are. We are ready to go. I just have to share my iPad and then we'll be ready. All right, so I don't know where we stopped. My computer thinks we're still mirroring my iPad. We are back. Let's try remirroring and we'll be good to go. Where did it stop? Or maybe I'll just go back to the answer choices and start there. Come on, computer, don't fail me now. Don't fail me now, iPad. Multiplicities. Okay, thank you, Leah. Don't fail me now. Can you tell I am a theater person? Quit. Let's try this again. Okay, go. Applications, reflector. Come on, you silly thing. Okay, it thinks it's reflecting, but I don't see my screen on my iPad. All right, we might have to do good old-fashioned me showing you the screen this way if this doesn't work. I'm going to try one more second, so don't leave me yet. I'm going to try it one more time. If it doesn't work, I'm going to have to do the good old-fashioned turn the screen around and show you. Okay, yeah, we're not working. So here's what we're going to do. Good old-fashioned, old school. Here we go. Here we are. This is what we're going to do. Okay, so this guy right here has no multiplicity. This guy right here has multiplicities. What I was saying was if, and this is not the case, but if this one had a plus sign, even though it's not squared, so even though it's not showing as x plus 3 squared like this one is right here, it would still be a multiplicity of 2 because you have 2 of the same factors being represented multiple times, hence the word multiplicity. So because of that, because it's not plus and plus, it's plus and minus, that's not a multiplicity. So A is not correct. The 0 that has multiplicity is the 3. And so even if I thought it was x plus 3, not x minus 3, even if that's what I thought, the 3 is the only one that has multiplicity. So x minus 4 can't be the right answer. So by process of elimination, I just figured out it was D. if I wasn't sure what that was. Now, remember, our zeros are going to be opposite of what the actual 0 is, because then remember, we set them equal to 0 and it becomes x equals 3. Like if we work backwards, x minus 3 equals 0, add 3 to both sides, x equals 3, that's my 0. So that's why the sign in the middle is opposite of what the actual 0 is. And this has no multiplicity, which tells me it goes straight through that x-axis. So therefore, our answer is D. Questions? Comments? Concerns? Awesome. Moving on to problem number 4. Oh, for the love, this problem is going to be so hard to do upside down. I am going to try again to mirror this iPad because this is going to be so hard to do upside down. Okay, the tires on an SUV have a diameter of 32 inches. The SUV runs over a nail, which sticks inside the tread of one of the tires. If the nail on the tire rotates at a speed of 8 revolutions per second, find the speed of the car in miles per hour. Find the speed of the car in miles per hour. All right, so this is a really interesting, fun problem. It has to do with a ton of conversions. And the idea of what a circle, like what is a circle? So I don't even know how I'm going to do this. We're just going to go for it. So the tires on an SUV have a diameter of 32 inches. Here's what I'm going to start with. I'm going to start with a picture because a picture is always the best way to start. So I'm going to draw a tire. Okay, here's my tire, right? And it has a diameter of 32 inches. You're not sure where to start? Draw a tire and write diameter equals, that was a terrible diameter, diameter equals 32 inches, right? There's my diameter. The SUV runs over a nail. Y'all, I literally did this the other day. So there's my nail, the little red thing, and which sticks inside the tread. If the nail on the tire rotates at a speed of 8 revolutions per second, find the speed of the car. So this, here's my tire. This nail that's right here is rotating at 8 revolutions per second. Okay. So I need to figure out how far this thing is going, right? Because I'm trying to figure out the speed of the car in miles per hour. I want miles per hour, not revolutions per second. They've already given us a speed of revolutions per second. I need to convert the revolutions to a distance. I need to convert that distance into miles, and I need to convert that time into hours. So there's a ton of conversions that are going to happen here. So all that said, there's a bunch of conversions that are going to happen here, right? So I am going to set up, I need to figure out what the distance is around this tire, because the distance around the tire is going to be 1 full revolution, right? What's the distance around a tire? It's not perimeter. What is it? Circumference. So circumference equals 2 pi r. Circumference equals 2 pi r, where r is the radius. What is the radius of that tire? Vocabulary, 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 y'all. The radius of that tire is half the distance of the diameter, right? So the diameter is 32. The radius is going to be 16 because the radius is going to be 32 divided by 2. So circumference, I can do this part upside down. Circumference is going to equal 2 pi times 16. Well, 2 pi times 16 is going to be 32 pi. And 32 pi is going to be 32 times 2.14, right? Pulling out my handy dandy calculator. 32 times 3.14 is 100.48. So the circumference is 100.48 inches. That is the circumference of the tire. So we are traveling at 100.48 inches per revolution. Well, I need to figure out how much per second. If we're doing 8 revolutions per second, and this is 1 revolution, I need to figure out how many inches per second I'm moving. So I just need to multiply this times 8. So multiply times 8, and that's going to give me 800. Whoops. That's going to give me 803.84 inches per second. There's my first ratio, my unit ratio right there. There's my first ratio right there, right? Now what? Now I need to do all of my conversions. Remember, I'm going to do a conversion path because I need to get all of my conversions to go from inches per second to miles per hour. I personally like to do one conversion at a time. So I like to do either my distance or my time. I don't like to do both. So I'm going to do either inches to miles, or I'm going to do seconds to hours. I'm not going to try to do them both at the same time. I'm going to convert my distance first. I don't know why. It just seems like a better idea. So you can do your time first. It doesn't matter. So I'm going to convert this inches into miles. So I need to go inches to feet to miles. Off to the side, I'm just going to write that 1 mile equals 5,280 feet. I have to look that up every single time. And 1 foot equals 12 inches. Okay. So I need a pathway. So I'm going from inches to miles. So in order for these conversion ratios to work, you have to put inches across from each other. So I'm not going to put inches up here. I'm going to put inches down here. So 1 foot equals 12 inches because I'm converting from inches to feet to miles, right? So this, because I have a 1 and a 1, I'm going to divide these because I end up with 803.84 divided by 12. That's going to equal 66.987 feet per second. Now I need to convert feet. So I know feet is up here. I'm going to keep feet down here to miles. (5,280 feet equals 1 mile. So I'm going to divide 66.987 feet divided by 5,280. 66.987 feet divided by 5,280. That equals, we're going to continue our journey up on the top. That equals 0.012687. I like to extend those kinds of decimals out pretty far. Miles per second. Now I'm going to do my time. So now my seconds are going to be on top because I'm doing time and I need to keep consistency here, right? So I'm going to convert seconds to minutes to hours. So 60 seconds in 1 minute. Now you notice we're not dividing, we're multiplying straight across. So multiply that crazy decimal times 60.7612159 minutes. Nope. Miles per minute. And now I'm going to convert that into hours. 60 minutes in 1 hour. Multiply that crazy decimal times 60. And I get 45.7. Which is D. Y'all, that is a ton of conversions. Now, you may not have to do those conversions, but you're going to have to do some sort of conversion. So it's important that you know that whole conversion process because you're going to have to do some sort of conversion no matter what test you're doing. Did all of that make sense? That was kind of a crazy long problem that was really hard to do upside down, but we did it. Obviously, it would be more ideal if it was on the screen, but that's okay. Questions, comments, concerns? Thinking about as we're working through these problems, if you're like, ooh, that was a good problem. Can you do something else similar to that next week? Or, ooh, can you do another conversion problem? Or, oh, you didn't do anything that related to triangles this week. Can you do a problem that's specifically like whatever it is, let me know because it helps me craft the upcoming sessions for your needs because that's really why we're here is to support you. All right, let's go ahead and move on to problem number 5. Ooh, this is a good one too. All right. Triangle DEF and triangle GHI are given. DF and GI are congruent. Angle D and angle G are equal, and EF and HI are congruent. Which theorem or postulate would prove that triangle DEF is congruent to triangle GHI? Which theorem or postulate would prove that triangle DEF is congruent to triangle GHI? Side, side, side. Angle, side, angle, angle, side, angle, side, angle, or the triangles are not necessarily congruent. So the first thing I'm going to do with this kind of problem is draw a picture so that I can see what we're working with. So I have triangle DEF and I have triangle GHI. So I'm going to draw them here. Triangle DEF and GHI. DEF GHI. Okay. Oops, I meant to draw GHI in pink. Let's go ahead and switch that. Okay. DF and GI are congruent. This is congruent to this. Congruent meaning the same size. Angle D and angle G are equal. Okay. And EF and HI are congruent. EF and HI are congruent. Which theorem or postulate would prove that triangle DEF is congruent to triangle GHI? So we're trying to prove that these triangles are indeed congruent. So side, side, side is not a congruence postulate. Side, side, side says all the sides are the same. Sorry, flip that. Side, side, side is. Angle, angle, angle is not a congruency. Side, side, side is definitely a congruency postulate. Angle, angle, angle is not. Because we can have the same angles and we can expand that triangle proportionally and have different sides. But if all of our sides are the same, then all of our angles are the same. However, we don't know if this third side is congruent. We were not given that that third side is congruent. So I cannot use side, side, side because I wasn't given that that side is congruent. Angle, angle, side. Well, I wasn't given two angles. I was given two sides in an angle. So it's not going to be B or D because I was not given two angles. What I was given was two sides in an angle. However, what I want you to notice about this is that it's side, angle, side, and the angle is sandwiched between the two sides. In these images, is the angle sandwiched between the two sides? Is the angle sandwiched between the two sides? No, it would have to be this angle right here for it to be side, angle, side. And because it's not, we cannot prove that these triangles are congruent. We cannot prove that these triangles are congruent. Now, with a angle, angle, side, so let's explore that for a minute. With angle, angle, side, which would be something like this, where it's not sandwiched. Angle, angle, side is not sandwiched. This is a congruency postulate. Angle, angle, side is a congruent postulate. Angle, side, angle would be sandwiched. So angle, side, angle would look something like this. That would be angle, side, angle. Purple would be angle, angle, side. If I have angle, angle, side, then that is a congruency postulate. Angle, side, side, or side, side, angle is not a congruency postulate. And y'all, the way I remember it is actually not a good way, but you know what? I hope it helps you. When I write it out, angle, angle, side works. This one is a postulate. Side, side, angle, where it's not sandwiched, does not work. And if I wrote it backwards, if I wrote it angle, side, side, it's a bad word, which means it does not work for triangular congruency. If I write it angle, side, side, ASS, that does not work because it's a bad word. So you cannot do triangle congruency with it. I hope that helps. Stick it in your brain because it helped me and I never, ever, ever used angle, side, side because it doesn't work. All right, let's go ahead and move on to the next problem. Listen, sometimes we just got to do what we got to do to remember this stuff, right? Because let's be honest, you're never going to use that again. Like, unless you are an architect and you need to know if two things are congruent, I don't know, you're never going to use that again. So whatever you have to do, you're never going to forget me telling you that in a Happy New Year glasses outfit. So you're welcome for that. Problem number, some of these I'm just going to have to skip because they are just too hard to do upside down. Ooh, problem number 6, we can do the right side up because it's really just a whole big conversation. So we can do this. And if you notice the stars by all of these problems, that means that they were specifically requested problems or specifically requested topics. So just know that there are plenty of things that we are doing that are specifically requested by you. And that's the goal, is to have problems that are specifically requested by you, whether they're exact problems or modified problems or content or subject like topics. This is for you. All right. Miss Sink is planning a lesson that will use mathematical modeling to introduce students in the 8th grade mathematics class to quadratic functions. Which of the following is the best framework to use to demonstrate mathematical modeling of quadratic functions? A, demonstrating the motion of a vehicle moving at a constant rate and asking the students to find an algebraic representation of the distance traveled as a function of time. B, having the students calculate the vertex and x-intercepts of a graph and of various parabolas in the xy plane. C, demonstrating projectile motion with a computer simulation and asking the students to take measurements and find an algebraic representation of the traced path of motion. Or D, demonstrating the motion of a falling object with a computer simulation and saying that the height of the object as a function of time can be described with a quadratic function. All right, so we've got a lesson that's using modeling to introduce students to quadratic functions. We're introducing students to quadratic functions using modeling. That is the key word. We are using modeling to demonstrate quadratic functions. So already B is not going to be the right answer because having them calculate the vertex and x-intercepts is not a model of a quadratic function. Y'all, the most important part about these kinds of super duper wordy problems, which show up on all of our tests, let's be honest, it's a math test and we have to do a whole bunch of reading comprehension, is you have to pay attention to what they're asking for. They want a model. They want a mathematical model to introduce students. So if we want a mathematical model to introduce students, we're not trying to calculate vertex and x-intercepts using a bunch of graphs. We're trying to find something that's going to model that, right? And I know that a quadratic function does something like this. So it's not constant. This is not the same all the way up and down. So demonstrate that the motion of a moving vehicle at a constant rate, that's going to be a linear function. A constant rate is going to be a linear function. It is not going to be a quadratic. So A is not the correct answer. Demonstrating projectile motion with a computer simulation, or demonstrating the motion of a falling object with a computer simulation. So these are both computer simulations, which is mathematical modeling. Which of these is going to be a quadratic function? Y'all, look at this. Probably the one that says quadratic function. Now, if you are taking these tests, you should know that a falling object is modeled by a quadratic function. Some of these pretty basic models, like constant rate is going to be a line. A falling object is going to be a quadratic function. When we throw an object, it follows a parabolic path. That kind of stuff is just important to know. It's not critical information, but it's definitely going to make your life easier when you're trying to muddle through some of these problems that are a little bit thicker and wordier. Next week, yes, let's go ahead and talk about next week. Hello, Marcos. I know I've seen you before and I can't remember your name. I feel like it's Marcos. Happy New Year, but I can't remember. Let me know. Let's go ahead and go to the next week slide. Next week, some sort of question involving velocity and time. You got it. Anything else that you want to see me go over in the upcoming weeks? Valeria, if you are here, I was able to get through a couple of the problems that you requested. The rest of those problems will be in the upcoming, like in the next week. I just wasn't able to get through all of them, but I promise I will get to them. If there's anything else you want to see, let me know in the comment box. I'll hang out for a minute or two. I am going to throw it back over to Dr. A to close us out. But I will definitely see. I thought it was Marco. I will definitely see you next week. I will not be wearing my Happy New Year glasses because it's not going to be a it'll be a Happy New Year, but it's not going to be the New Year next week. Have a great, fantastic week. Leah, you as well. And I will see you all in a week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.